application of this type of stuff, which most of your questions you will see are going to be like this. So an application of charged particles moving in a circular path in the presence of an external magnetic field is a mass spectrometer. Okay? This mass spectrometer is an instrument used to calculate the mass of different ions and charged particles. So this is actually more of a used in chemistry, okay, to study particles and different solution things like that. But how it works is physics, right? So a mass, there are several basic components to this. So first you have your ionizer. This is a method to charge neutral particles by forcing the particles to lose electrons. So this is a big important one. We have our ionizer. So on here, gas enters here, filament current ionizes the gas. So here is our ionizer. Then we have the accelerator. So an electric field created by parallel plates is used to accelerate the charged particle. The electric field could also have an overlapping magnetic field. So here is where we have the accelerator. Okay, so there's our accelerator. So it's probably like if this, say, it ionizes it to be negative, this parallel plate will be a positive because it wants to accelerate it there. Okay, so then the particle is shot out of the accelerator. So it's like when you're trying to interpret your questions, look for the speed as it comes out of the accelerator. But here, where it kind of starts and accelerates to, generally, unless it tells you, your VI will equal 0, okay? Because it's starting it from rest, so it's like saying it has some gas, and then it accelerates it, okay? And then here, you would treat this like kind of like your VF is coming out. Now, this speed is the speed that you put in to like your magnetic formulas. So, like we were just doing, here, that's the speed, okay? When it's talking about speed for these formulas, it's the speed that's in the magnetic field, right? So you need to know the speed as it comes out of here, because then it goes into a magnetic field. You see that?
So VF, why is VF 0?
It's not. Oh, sorry. Why would I put that? I'm sorry, Hayden. I don't even know, okay? So VF is not 0. I don't know why I put that. Thanks for catching that. So it's that speed that's coming out, that's the one that you put into the magnetic formula. Okay, so just as you're interpreting these questions, that's what it's talking about. Okay, so then next is a separator. Okay, this is the magnetic field that is used to separate the particles based on their radius of their curvatures. So this is like, so separator. Okay, so this is the separator. So this is a magnetic field. So these are like two magnets here, and it's creating a magnetic field depending on, so the lighter particles will move faster, which means the magnetic force will be stronger, resulting in a smaller radius of the curvature. So the separator is super kind of the pinnacle of this, and it helps chemists know kind of the differences between the particles. So then left is the detector. That's at the end here. So depending on how these land, will give detection based on like how big it is. Okay? So that's the ions land there. So now I'm just going to show you a video that helps explain